Very good morning, class. In the previous video, we have seen that how we can connect n number of pulleys together so that the mechanical advantage and the velocity ratio of the simple machine can be increased. Today we will see another method to connect n number of pulleys in a system. This method is known as block and tackle system. What does it mean? In this method, pulleys are joined in two blocks, the upper block and the lower block. In the upper block of the pulleys are basically fixed to a rigid support. That means in the upper block we have fixed pulleys, and in the lower block system we have movable pulley. That means they are not supported by a rigid support. And obviously the load is connected to the lower block pulleys because they are movable. One more thing you have to understand in this concept, that the number of pulleys on the upper and lower block, the number of pulleys in the upper block is always one more or equal to the number of pulleys in the lower block. Like suppose in the lower block, if we have two movable pulley, then in the upper block we might have either two pulleys or three pulleys, not more than that, right? So let's see how this system works and how we can calculate the mechanical advantage and the velocity ratio as well as the efficiency of the system. So you can, in the diagram you can see we have a block and tackle system. We have two blocks of pulleys. These are the upper block, which is, you can see it is fixed on the rigid support, and these are the lower block, which is the movable pulley, and it is fixed by the load. Now see, it is very easy to find the mechanical advantage velocity ratio once you know how to wound the wire or the string in these pulleys. That is the most important part of this concept. You must how the string is wound in these pulleys. One thing you must know that whenever we apply the effort, we try to effort in the downward direction. That means the effort is acting in this direction. We are creating the effort downward direction. Now, so we'll start from here, right? Now this string will go like this, and it will directly reaches to the pulley on the lower block like this. Okay, simple. Then take the string to the next upper block. It will go like this, right? Simple. We are taking the string like from the upper block, then we go to the next pulley in the lower block, then again on the upper block, then we come next on the lower block, right? And finally it will connect by this hook. Okay, so this is, we can see, the most important thing, how to connect the string in the pulley. Now the work is easy. Next, first step, connect the string in the pulley, right? Next step, show the tension acting in the string. Now you must have noticed one thing, that I have used one string only. Like in the previous case, in the combination of pulleys, we have taken several strings, but in this case we used a common string. And if you remember, I told you, in a common string the tension remains always same. So if the tension is T here, then here it will be T also T here, right? Then again here is also T, and in the last case here it is also T, here it is also T. Okay, we are applying effort toward this direction. Okay, let's find the mechanical advantage. To find the mechanical advantage, first write the effort. Effort, as you can see here, it is equals to the only T, equation number 1. Now load. Let's see load, how much load is balanced by how much tension. See here, the load is balanced by 1, 2, 3 and 4. 4 tension in the string. That means each tension is providing some force to balance this load. Again you can see here, this load is balanced by 1, 2, 3 and 4 tensions. That means load is equals to 4P, equation number 2, right? So what will be the mechanical advantage? MA, that will be load upon effort, that is 4P upon T, which is 4. So in this case mechanical advantage will be 4, right? So similarly, if we have n number of pulleys, here we have 4 pulleys. If we have n number of pulleys, then for n number of pulleys, what will be E? E will be T only, but the L will become N into T, which gives you mechanical advantage is equals to N. So in such numericals, it's quite easy. Just count the number of pulleys and that will be the mechanical advantage of the system. If there are 4 pulleys, MA will be 4. If there are 3 pulleys, MA will be 3. If there are 5 pulleys, MA will be 5. Let's say one more example when we have 5 pulleys, because these are 4 pulley system. Let's say when we have 5 pulleys, and if you remember I told you 5 pulleys, that means in one block there might be 3 pulleys and in the second block there might be 2 pulleys, right? So I told you that in the upper block we can have one more extra pulley, right? We can't have 3 pulley downwards. Okay, so let's have a system having 5 pulleys. Now you can see here we have 5 pulleys, and I have not shown the string so that you can understand how to apply the string here, right? So I told you that effort is always we apply the effort in the downward direction. So we'll start from here, that here we are applying the effort E, right? Then wound this string from the upper block to the first pulley in the lower block. So it's going like this, and it will pass through the lower block of pulley. Now it will come to the second pulley in the upper block, like this, completed, and will go around the next pulley in the down block, only one pulley is left here. You go like this, and finally it will connect to this hook. So this is how we wound the string around the pulleys. Now let's apply the tension. Again, because we have wound the whole system with a single string, that means the tension in every string will be same. So let's say it will be T. It will be T here, right? T, 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 and the last T. Okay, so we have shown the tension in the string. What will be effort? Effort E, you can see the effort is balanced by the single tension T. Equation number 1. Load. Load is balanced by how much tension? See here. 1, 2, 3, 4 and 5. load is balanced by 5 tension here, so load will be equals to 5T. Right, so what will be MA then? Mechanical advantage, we know that is load upon effort, and that will be 5. If we see here, what is the relation between load and effort? Here, the effort is basically load upon 5. That means if we are lifting 100 kg weight, so we have to apply the effort of only 20 kg, right? Because load is L upon 5. So from here, if we have n number of pulleys, right, then L will be n into T, right? Effort will be L upon N, and the MA, mechanical advantage, will be equals to N. That means just count the number of pulley in the system, and that will be the mechanical advantage of the system. Now let's talk about the velocity ratio and the efficiency of the this system. Let's calculate the velocity ratio of the system. Now, suppose the load is shifted d distance upward. What will happen? If the load shifted d distance upward, that means each string will loosen by the same amount of the distance. That means if load is moving upward with distance d, then this string will loosen by the distance d. This string will also loosen by distance d. This. That means all the string will loosen by the distance d. Right? Again, see here, the load is shifted up over distance d. Now the effect will come on each string d, 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 and d. So the outer string will loosen by how much distance? It will be loosened by d plus d, 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 and d. That means 1, 2, 3, 4, 5, 5d. Hence, here string will be loosened by the distance 5d, and from here we can pull this effort downward, and that will be the distance traveled by the effort, that will be 5d. So here, if the load is moved up by distance d, right? That means we have distance traveled by load is d. Then each string loosened by distance d. So total distance covered by the effort will be 5 into d, right? So that means we get DE. DE will be 5d. So now we have DL, we have DE, so we can find the velocity ratio. Velocity ratio VR will be DE upon DL, that is 5. So again, it's quite easy to find the VR in this case. Just count the number of pulleys, right? So let's see the general case. You can take the screenshot of this part. For n number of pulleys, pulleys, DL will be D, but BE will be N into D. Hence, VR will be N. So this is how we can find the velocity ratio. Let's see the efficiency of the system. The efficiency eta. You know that eta is equals to mechanical advantage to the velocity ratio, MA upon VR into 100. And we know that in both the case VR and mechanical both is N. So that will be 100%. Okay. So that's how this system of pulley works. So the efficiency is 100%. Some student thinks that like I told you that if we have to overcome the load of 100 Newton, we have to apply only the effort of 20 Newton, right? If we have 5 number of pulleys. So some students think that are we gaining the energy here? So where that means where the energy come from, right? Of 100 Newton we are applying only 20 Newton. That means the rest amount of 80 Newton, who is applying this energy? But actually this is not the case. This system is only works as the force multiplier, because you can see here when the load is only covered a distance D, we have to apply the effort so that the effort covered distance 5 times D. So load is covering this distance, but the effort is going this much. So okay, it's okay that we are applying the less force, but we are covering more distance, right? So here force is more, but the distance is less. But in this case we are applying less force but covering more distance. So work done in both the cases will be same. So that means there will no gain in the energy. So now we have completed the chapter machine, each and every cases. In the next video I will do some numerical problem on this system of the pulleys. Thank you so much, class.